Greetings, everyone. All right, so let's start talking about logarithms, and this is what the basic function looks like. And just so we're all on the same page, it's read, or you say, log base b of x is equal to y. But let's actually get in and understand what that means. And so we have to try to put this into a context. And so I'm going to go back to where this comes from, and we're dealing with an exponential like this. Part of our discussion here in this chapter was trying to figure out the inverse of a function. And in an earlier problem, we had to figure out the inverse of the exponential, and we were trying to do that by using the technique, or we were supposed to try to do that by using the technique of switching the variables x and y and solving for y. And this is where you get stuck, or where most students get stuck, because before the introduction of logarithms, there isn't a way that we have to directly rewrite this in terms of y. It requires that we define a new function so that we can get at the y and actually solve for that variable. And so, in order to generate the properties of the logarithm, even before we get to be concerned about the function in particular, we actually would start to work out the properties of the exponential and then relate the properties of the exponential to its inverse. And then we went about and started thinking about the function itself, the logarithm. But since we've already talked about that, I'm just going to jump right in and then we'll make the connection in just a moment. So whenever we have an expression written like this, what we're looking at right now, this is called our exponential form because it's written with some base and some value in the exponent. In this case, that value is y. When we want to rewrite this in log form, I should probably note this on there. This is exponential form. If we want to write it in log form, we just got to put things in the right spot and understand what goes where. So let me go back to this form for just a moment. Notice the b that I put down here in red. As I said earlier, it's log base b of x. So the base is what goes as the subscript next to the log function. So when I rewrite this expression over here, what's my base? Well, my base is the 2. Okay, so that's the base, and that needs to go next to the log function. Whoops, do that. So it's going to be log base 2 of what? Well, for the logs, the input to the log function is the output of the exponential over here. So this value over here is what's going to be inputted into the log function. So that's what's going to go right next to this right here, right next to the log expression. And then from there, the output of the log function is always, 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 did I say that enough? Always the exponent of the exponential, the exponent on the base. And so in this case here, our exponent is y. That is the output of the log function. So rewriting, x equals 2 to the power of y, in log form, we're going to get log base 2 of x equals y. Okay, so this is our log form right here. And you should be able to switch back and forth between the two when needed, maybe to get an understanding, to generate tables of values, to find inverses. There's a number of ways you might want to be able to switch back and forth. All right, so the inverses of each other, the two functions that are inverses of each other, are these two functions right here. This is the inverse of this one, okay? Now remember, the inverse has certain qualities, or rather the function and its inverse have certain qualities in relation to each other. So if we think about the graph of y equals 2 to the x for a quick sketch, I'll show you a precise picture in just a moment. It looks something like this. And then if I were to plot the line of reflection for a function and its inverse, it's going to be the line y equals x. And so then the inverse is going to be what I get when I reflect the make that a little closer here. When I reflect the exponential about y equals x. So that's what I should have in mind. And so let's take a look at a more precise picture of this that I got from Desmos. So you can see the blue one up here. This is the y equals 2 to the x. That's our exponential. And then you can see down over here, the red one, that is the log, y equals log base 2 of x. And so, I mean, you could go through and try to start identifying different points where that they have in common by that relationship where we flip x and y to get from one to the other. So, for instance, right here, the graph of the exponential goes to the point 0, 1. So when I switch the point to get the inverse point, it's going to be 1, 0, which is this point right here. Another point on the graph of the exponential is the point 1, 2, because if I plug in 1 as my exponent to that expression up here, then I'm going to get 2 as the output. So if I flip that point around to get the inverse point, 2, 1, I get that point right here. And we can continue doing that over and over again to go from the original function graph, the exponential, to its inverse, the log. In fact, we could do it in either direction. I could start with points on the inverse and switch those, or points on the log and switch those, get points on the exponential. It doesn't matter which way you start. And then there were also some properties that we were dealing with in relation to domain and range. And so for the exponential, we said the domain was all reals, negative infinity, less than x, less than infinity. And then we said the range were all the positive values, so y greater than 0. Never actually equals 0, even though down over here it gets really, really close. It still never actually does touch 0, so the outputs are all greater than 0. Well, similarly for the log graph, the inverse, I can write the domain and range. Okay, the domain has to come from the range of the exponential. So now it's going to be x greater than 0. And that makes sense. If I look at my graph, the red graph never does go to the left of the y-axis, never has x values that are negative, never even has x values that are 0. It comes close, but never actually gets there. The range comes from the domain of the exponential, so that's going to be negative infinity less than y less than infinity. Okay, I'm squeezing it in there, and I apologize for that, but hopefully you can see it. A couple other things. Remember, the graph of the exponential has the horizontal asymptote of y equals 0. And so that's at y equals 0. And so now when I look at the graph of the, one second here. If I look at the graph of the inverse here, the log, then that has, my goodness, I'm struggling here with my app. That has a vertical asymptote at y equals 0. I'm sorry, x equals 0. Too much playing around with technology here. I apologize for the pauses there. So all the relationships between the exponential and its inverse, the log, should make sense, and we should be able to see these connections and exploit those connections so that we can go from one graph to the other as needed. If I'm a little unclear about the log graph, then I look at its exponential inverse and get the properties from there and switch x's and y's to go back and figure out the graphs, the properties I need for the log function. And so those are really the basics that we need to have down. I want to go through a couple quick numerical examples to make sure we understand some properties here. So if I have, for instance, log base 3 of 9, I should be able to answer that question or figure out what the answer to this is, what this equals, without even using a calculator, and hopefully without too much thinking. Okay, I should be able to eventually recognize those answers quickly. Well, just to make sure we understand, let's look at what this means. If this is some number y, then if I rewrite this in exponential form, I got base 3, the answer to the log function is the exponent, so answer of y is going to be the exponent on the 3, and that's going to be equal to the input 9. And so then I have to ask myself, for what value y would I raise the 3 to in order to get 9? 3 to what power equals 9? Well, obviously, I hope that's obvious, y has to be 2, because 3 squared, or 3 to the second power, is equal to 9. Let's try another one. Let's say we have log base, let's go base 2 of 16. So what you have to think about, and you don't have to rewrite it every time. Eventually you can get to the point where you can just think it through in your mind without writing it down. This means 2 is my base. I'm going to raise it to the power of y, and I have to get 16. Well, 2 to what power has to equal 16? Well, hopefully you know that that's power has got to be 4, so y has to be equal to 4. And that's the answer to that question. Now, log values can be really difficult to calculate. If I did log base 3 of, let's say, 30, I don't know the answer to that specifically off the top of my head. And even if I try to rewrite it, I still am not going to get an exact answer without using some technology. Because if I think about this, I have to raise 3 to some power, the power being y, and I have to get 30. I don't know a number for that. I don't have it memorized. I've never studied that specifically. If I raise 3 to the third power, I do know that that's 27. I do know that if I raise 3 to the fourth power, I get 81. So the answer for y has to be somewhere between those two values, okay? So y is going to be somewhere between 3 and 4. Let me rewrite this mess. Hold on. So I know that y is trapped somewhere between 3 and 4, because if I put 3 for y, it's too small. If I put 4 for y, my answer is too big. And so y has to be somewhere between 3 and 4, although it's going to be closer to 3, because 30 is closer to 27 than it is to 81. So that's why, having technology is important for this. And when we look at the graphs, they don't hit a whole bunch of nice points that are easy to identify. They have a few that are always easy to identify, like 1, 0 is on every graph of the log function. And then b, comma, 1 is also there, b being the base. But the other values are often difficult to calculate. So if I remember the definition and I think clearly enough about it, I can get a ballpark of what's going on, but technology is going to be needed to help me get more precise answers. I hope that's helps you get a better understanding of the foundations for logs. Go study.